Now we know what we need to do, let's do the full hypothesis test. First thing I do is write down the information from the question. Okay, X is the number of broken pots. N is 50. We're still looking at a probability of 0.2 and we observe 6 broken pots. Significance level now is 5% we've been asked to look at. Okay, so first mark comes from saying your X can be modelled binomially with N is 50 and P equals 0.2. State your null hypothesis. We are testing whether the probability is still 0.2. Alternative hypothesis, we are testing whether the probability has dropped. So it's less than 0.2. It says that here. Does this reduce the probability? Now let's have a look. First method. Probability of X being less than or equal to 6 when N is 50 and the probability is 0.2. We look it up in the book. N is 50, probability 0.2, 0.1034. 0.1034. That's 10.34%. Okay, there's a 10% chance of that happening. That is that's greater than the significance level. Okay, so it's 10% chance of happening. We're only interested if there's only a 5% chance of it happening. Okay, so this means that probably our P equals 0.2 is correct. There's a 10% chance of that happening. We would only think that this isn't correct if there was a less than 5% chance of it happening. Okay, so there is insufficient evidence to reject H naught. So that's part 1 of your conclusion. Insufficient evidence to reject H naught. And you must put that into context. Therefore, no evidence that increasing batch size decreases probability of broken pots.